So you can see here that the cold fire doesn't burn my finger at all. Okay, so let me explain to you how I'm doing this. So what I have inside here is an electrode. Now at this electrode, I'm building up a very high potential, an alternating current. And so it's building up to extremely high voltages in the tens of thousands of volts. And it's alternating extremely fast. And what happens is it builds up an extremely high potential, so high that eventually the electrons start getting pulled off in the air around it. So it ionizes the gas around it. Now normally what would happen around this electrode is it would get extremely hot. And it would get so hot that it would be able to burn anything that touches the plasma. But the goal here is now to generate a cold plasma. So basically we want the gas around it to be cold but still keep the free electrons. And the way that we do that is by taking away the thermal energy of the gas. So what we need is a gas that can ionize very easily, and so it can lose its electrons easily, and also has a very high thermal conductivity. And what we do is we flow that gas through here, and as the gas goes through this glass tube around the electrode, the glass tube absorbs some of the thermal energy of the ions. And so we adjust the flow rate of the gas until it's just high enough so that the gas is flowing fast enough so that the atoms themselves don't get to a hot temperature, but they're still ionized. So basically what we're doing is we're taking away the thermal energy of the ions themselves, but not the electrons. So we still have free electrons that are generating a plasma, but the plasma is not hot to the touch because those electrons, even though they're tens of thousands of degrees, their mass is so low that they can't generate a lot of thermal energy when it hits my finger or hits a match. And so basically what we've created now is cold fire or cold plasma. So it's a plasma that has very high electron temperature but low gas temperature or ion temperature. And the gas that I'm going to be using to do this is helium. And the reason I chose helium is because helium can be easily ionized, but it also has a very high thermal conductivity. So it can dissipate the heat quickly and it can ionize quickly. So the temperature of these electrons can be tens of thousands of degrees, but still they have such a low mass that they can't transfer their thermal energy to the match to get it to high enough temperature to light it on fire. So you can see here that the cold fire doesn't burn my finger at all. I can leave it here as long as I want. So fire can be defined as a partial plasma, mainly because its level of ionization is very low. It has a very, very low percentage of ionized atoms compared to the total number of atoms in the gas. So we know that fire is a partial plasma, but the problem is that it's still really hot, even though it's a very low-grade plasma. In fact, anytime you have a plasma, it's usually extremely hot. For example, arc welders that use a plasma generated between two electrodes can get around 20,000 degrees Celsius. Very hot. Another example of extremely hot plasma is lightning. Now there's actually more than one way to make this cold fire, but in my setup what was happening is that you yourself touching the fire were part of the circuit. Because it was an alternating current at extremely high voltages, basically the plasma was jumping from the electrode itself to your finger and traveling back and forth through your finger and the circuit. Basically it's the same way that a Tesla coil works or a plasma ball works. You're part of the circuit, you're grounded, and it's at a very high or low voltage, and so when you touch it, the electrons jump back and forth between your finger and the electrode. But either way, the goal in both of these scenarios is to generate a plasma. But you want to be able to keep the ions or gas in that plasma cool while still allowing the electrons to be free. And so basically these hot electrons can't really do much to your finger or a match or a piece of paper that comes near it. But if you have something extremely small like a bacteria or virus, then those high thermal energy electrons can actually damage them. So it can sterilize things but not burn you. In fact, this cold plasma technology is being used today to synthesize different chemicals. It's even used in dentistry. You can sterilize parts of the mouth without burning somebody. So cold fire or cold plasma is a good method to use when you need to sterilize something but you don't want to burn it or expose it to any chemicals or high temperature. And thanks again for watching.